He has been in the geosynthetic industry for over 30 years, the majority of the time with Solmax, Tenkate formerly, the world's largest manufacturer of the all geosynthetics varieties. They are producing all geosynthetic varieties. He has held positions in sales, technical, quality, marketing, and executive management. And he has been active in the IGS, GMA, ASTM, and ASCA GI, and other industry organizations. He is currently a consultant with a global client base. Now I would like to invite Boyd to speak about the sustainable use of geosynthetics in landfill and hydraulic applications worldwide.
Okay. Oh, hi everybody. Hi folks at home. The folks at home are probably the people I'm talking to because there's a lot of old people in the audience here in person. Yeah, there's old people here. So I want to talk mainly to the younger people. Let me start with my caveats. If you saw me before, I was wearing a little button that said IGS on it, and I'm not wearing it now. This is my opinion and my opinion only. It has not been sanctioned by the IGS or anybody else. So that's the first thing you need to know. Second thing you need to know is that I am part of the worst population and community for the earth ever. I was an American who grew up in the baby boom. I am deeply ashamed of many of the things that I've done in terms of my sustainability behavior. I was one of those people with the frequent flyer cards who went in the lounges and got upgrades. I owned 18 cars over the course of my life. I think hundreds of years from now, when they look back at this period in Earth's history and human history, if we're still here, they're going to say, all these people owned cars? What the hell was they thinking? I've chaired the IGS Sustainability Committee, so that's a little bit plus. And I'm attempting to improve my sustainability contributions and performance. And I've done the reading and the math, so I'm going to start with a quiz. We're May now, we're well into the year. How many, and I only get this quiz from the people in the room, how many people in this room have read a book? Of an old paperback book, complete one end to the other. Okay, quite a few. That's a good sign. That's a good sign, because that's an important thing. When you do a presentation, you always tell them what you're going to tell them. I'm going to talk about sustainability for a little bit. I'm going to show you tons of pictures. I'm not going to get into any of the detail that Jorge or Kent did in terms of sustainability. I'm going to show you pictures of what geosynthetics is doing with a little bit of overview. A lot of hand waving on this is better. But then at the very end, I'm going to get into how sustainability contributions are being measured today. State of the practice, what you're doing if you really know what you're doing at this point. And that's particularly important. And then at the end, I'm going to give you another lecture on what I think you need to do to make the world a better place. So I always start, particularly when I gave American lectures. I'm an American person, but I haven't lived in America for about 10 years. So I always start with a quote from the Quran, because there's a certain segment of the American audience that reads that and just absolutely freaks out. And I want to identify those people right away so I can avoid talking to them later on. But what is said here is particularly important. You'll hear me mention books several times in the theme of this, and I'll recommend several books to you. Books are critical for passing knowledge and information around. And I also remind you of this quote by F. Scott Fitzgerald, none of this is black and white. There's shades of gray in everything, and that decision of what to do when there's not a clear alternative is what makes us human beings. And you need to keep both perspectives in mind while you're making your decision. So back to the Quran quote. Before I give you the books, I'm going to digress into this. You'll notice that the CO2 emissions thing that Jorge sent is very similar to the green portion of this, which is population. You cannot consider sustainability without talking about how many people we're trying to sustain. What was a sustainable behavior when there were 2 billion people on the planet is very different than what's sustainable when there are 6 or 8 or 10. Right now we've got about 8.5, depending on how accurately you count. We're on the way up to 10. The good news is this red line here, which is the birth rate. and the birth rate is declining. Hopefully it will continue to decline because I think we're above the limit of where we can sustain long term. Again, just my opinion. This came from the World in Data, which I consider to be a good source, but we need less people. We just, we've optimized things to get care, food, water for all the people we have, and we're not going to be able to continue it if the population grows up. And if we get to 10 billion, people are going to do things like, invade the country just below them to the south because they've got lots of good farmland that I'd like to have for my country. I view the invasion of Ukraine as a warning sign, and I think there are more of them coming. Because we're all here together, and these are the amount of resources we have, and that's it. There aren't any more. And if you think that this is an infinite amount of resources, you're absolutely wrong. And I'm going to give you a couple of personal stories to illustrate that. When I first started in this industry, I was given a job. And I was on the sales side. And when you were building a landfill in the United States when I first started, what you used for drainage was a picture of this rounded river rock. The golf ball's on there for scale. And these are rocks that had been in a river and they'd been tumbled. They didn't have rough angular edges. And it was very cheap and easy to go get this stuff and put it in your landfill for drainage. I was given the Go back. I'm not seeing everything on the slides, but I'll keep going. I was given the responsibility for selling drainage geocomposite products that replaced rounded river rock. And I did very well. I was extremely successful. This is, of course, because I am brilliant, right? I got some laughs for that. No, it's not because I'm brilliant. It's because the supply of rounded river rock at that particular time dried up. There was no more rounded river rock to get. We had used it all. The price went through the roof. And engineers were looking for alternatives for rounded river rock. So they used the drainage geocomposite that's supposed to be pictured up here. It's a crossover webbing with filters on the top and the bottom. And it's a real good replacement for rounded river rock. And that's why we succeeded, not because I was brilliant. But again, back to my resources point, we used it all up. And we're using up other stuff now. And if you think we're not, go to Google when we're all done today and enter China and sand. China has a fleet of ships that they send out to get sand because they've used all the sand in China. Qualification for my China comments, I lived there for about 3 years. They've used all the sand in China, so now they're sending their ships out into the South China Sea to get most of it. We can use all the stuff up. Believe me, we can. And since the young people discuss in MEMS, I included this. We are all in this together. None of us are going to succeed individually. I have a friend named Robert Yi in China. If he doesn't make it, I'm not going to make it. I have another friend, Jabalele, who lives down in South Africa. If the South African people don't make it, we're not going to make it. We are all in this together. So let me recommend a whole bunch of books for you, and I'll try and go quickly through this part. Probably the most important one is the first one, Daniel Kahneman, who died recently, Thinking Fast and Slow, talks about how we think as human beings. We think terribly. We follow stories. If somebody tells us something in a story versus just presenting us a fact, we fall for it hook, line, and sinker. The next one, If Nietzsche Were a Narwhal, addresses another human fallacy, human stupidity. God, we're dumb. We had COVID 3 years ago. Nobody met in person. We had disinfection stands all over the world. You walked into a store and there was a place to disinfect your hands. Well, COVID went away. We got rid of all that. We don't need that. So do you think that the animals would do that? Do you think that the animals went back to somewhere and they ate a bunch of stuff that killed people, that they would then the next year go back and try it again? Maybe it's different? No. There's 2 books here by Vlachal Smil. He's an author out of University of Manitoba, How the World Really Works, and he explains in engineering and scientific terms how the world really works. Limits to Growth was published in 1973 by Rachel Maddow. And their proposition is we can't continue to grow our way out of our problems. Eventually they're going to come home to roost, as they're coming home to roost with us now. And she pointed out the disconnection between economics and sustainable behavior in real good terms. Another good example of that is the middle book, Michael Sandel, What Money Can't Buy, The Moral Limits of Markets. I used to give most of my presentations with saying I was a capitalist. I'm still a capitalist, but we have to tie the economics to the sustainability. And I'm going to mention this in personal terms, in terms of tailings dams and fertilizer, the leftover fertilizer manufacture, etc. The Common Good is a good read, talks about, again, how we're all in this together. The Yuval Noah Harari book, which is sometimes called Humans, is a good history of how we've behaved in the past. And again, no spoiler alert, we behaved horribly. We go and consume everything and either come up with a technological fix to get past it or abandon the area. If global warming is your concern, the David Wallace Wells book is a good summary. And then Vladimir Smil got pissed because people didn't like his first book about the way the world works. People thought he was using erroneous assumptions. So he essentially rewrote the same book, but did it with numbers. 71 little vignettes with numbers about there are this many people in the world, people need this many kilocalories to eat, that means we have to grow this much food, and it's numbers don't lie, as the title of the book. Yikes. All right. Help me, please. At any time, I can go with a different one, but I'll keep going. Can you see the slide? Okay, good news. We've got a solution we're working towards, the United Nations Sustainability Development Goals. If you don't know what those are, you're part of the problem. But if you do know what those are, it's a way for us to make a sustainable planet. And we're all in this together. We got to have a goal. Okay, so I'm going to show you a whole bunch of pictures. This is a list of all the pictures I'm going to show you. And these are all applications of geosynthetics where geosynthetics offers sustainable benefits, something that humans need to survive on the planet. And we're going to start with this one. And I like this picture particularly because it talks about the layers. Geosynthetics are occasionally used alone, as Kent talked about with GCL, but very, very often they're used together. So this picture is a primary, this is a pond. This is an industrial pond for water storage. At the end down here, they've got their primary geomembrane. This dark layer here is a leak detection system. This is the secondary geomembrane in case something goes wrong. And then there's a GCL underneath to contain the something goes wrong and the subgrade underneath. So when I talk about geosynthetics, I may be talking about one layer, I may be talking about multiple layers. Oh yeah, the other thing I'm going to tell you is how to play the flute. Digression. Do you know how to play the flute, Sam? How to play the flute. You blow in one end and you move your fingers up and down the middle. That's kind of what I'm doing with this next set of pictures. Yikes. Okay, you're going to have to make the best of these pictures. This is a reservoir for potable water. We all need water. We just heard a lecture about that. Lined with a geomembrane barrier, necessary to hold on to the water at this arid area of the world. This is the same thing in the same type of area, except now this has a floating cover over the top. That white section that goes out actually floats out and encapsulates the water. Post 9/11, there was a big crush that people were going to come and poison our water. That didn't turn out not to be the case, but in some areas where there's a lot of transevaporation, that's an important one. This is probably my best slide for geomembrane barriers work. This is an aerial picture of Palo Verde nuclear power plant. Every other nuclear power plant in the world is located next to an ocean, as we learned from Fukushima, or a river or some large body of water. Nuclear power plants use a lot of water. In Phoenix, All the electricity for Phoenix and most of it for Las Vegas comes out of this facility. And where they get their water from is they collect all the waste from Phoenix, the wastewater, and they pump it into these ponds, they treat it, and eventually the good part of it gets used for water to cool the nuclear power plants. Very important that they work. And again, this is geomembrane barrier, and I'll give you some ideas of scale in some of these, but you're looking at about a little over a square kilometer of lined area, which is mainly the black areas. The white areas are ponds being replaced. These things really work, and these are the slides I present as evidence to that. I'm going to give you a couple tips about barrier systems, and one of them is you have to provide venting if you're going to generate gas underneath the barrier system. Because if you don't vent the gas that's underneath the system, it's going to make these big bubbles. And strong hydraulic forces, the picture on the right is from a canal in Florida, and it's concrete protected geomembrane, and those little concrete panels that you see being lifted up there, they're about 10 centimeters thick. So you get some idea of the forces involved. So that's tip number one, make sure you vent underneath your barrier. Some other applications, district heating. Again, things we used to do years ago that we stopped doing and we probably shouldn't have. District heating is, I don't know if it's popular here in the Netherlands, but where you have an industrial process, for example, that generates a whole lot of heat and energy, you can capture that heat and energy, store it in really hot water, and use it as a heating function for the rest of the town. And this one's from Germany, they got a couple of these. Pumped water storage, Kent mentioned that. Here's another picture of one. This helps us manage our electrical load. When you have low capacity, you use the electricity the excess electricity that you have to pump water up. When you need electrical generation, you run that water through a turbine and generate electricity. Wow, that's a really bad picture, and I need it to be good. Okay, there's the good one. Okay, let's talk for 30 seconds about electric cars. I'm not sure electric cars are a good thing, but the batteries that you need to run electric cars come with a big load of lithium. I visited several times a site in China that looks like this. There are 4 of these, and just to give you some idea of scale, these poles that you see in the back, there's 1, 2, 3, 4 of them across. Those are high power tension cables, so there's about 800 to 900 meters between each one of those. There's 4 of these ponds, and each of those ponds is in a different quadrant, so this is just looking at across one of the ponds. If you use a geomembrane in your pond, you're about 4 times as efficient in collecting lithium as if you don't use a geomembrane. So the geomembranes are making a contribution to batteries, which are making this critical contribution to electric cars, and I hope that electric cars are making a critical contribution to our planet. And in any case, we're trying something, for God's sake. Most of the applications for these products are also landfills. And landfills are particularly important because it's where we send all our garbage. You would be amazed how many seemingly intelligent people you talk to, and you ask them, what happens when you flush the toilet in your house? Where does it go? What happens to it? And they have no idea. And many people also think the same way about their garbage. I was able to live in Paris for several years, and the Parisian gatherers, the waste collectors, went on strike, as the French do occasionally, and decided they were going to stop picking up the garbage. So this is what 2 days of garbage in the Parisian streets look like. So you need landfills. You need a place to put this. These landfills are highly engineered. Kent gave some illustration of this. They have composite liner systems, multiple layers that come with a geomembrane as the principal barrier, a GCL underneath to seal off any problems in the geomembrane, and they're quite big. You see the picture there, the front end loader down at the bottom, and this is where all our waste goes. Again, my predictions for the future, I am very certain that 40, 50 years from now, we're going to be going to these landfills and digging stuff out and mining it because we're throwing stuff away that's important. These come very big. This is a picture I took in China. You can get some idea of the scale of these, again, from the front end loader that's there. And this goes off to the horizon, but we generate a whole lot of waste. And we need to put this waste somewhere, and the geosynthetics allow us to put it into landfills, and if we don't do it, it's not sustainable. Some of these are built in canyons. Here's a picture of a canyon landfill. Again, the scale is pretty impressive. In the old days, that's where all our waste used to go without the liners. We used to take all the waste out to a ravine and dump it all in there. That's what they did in China. When I lived in China, there were 7 or 8 large cities where they had no longer viable drinking groundwater. They had poisoned their groundwater with the leachate from the landfill because they hadn't collected it. We put our nastiest stuff in there. This is a picture of an installation at Oak Ridge National Laboratory in Tennessee in the United States. This is a landfill that's going to take radionucleotide contaminated waste. I told you I was going to throw a couple side benefits at you. This is another one. This installation is actually happening at night. And the reason it's happening at night is because you need to keep the wrinkles out of these geomembranes. You need to keep from putting stress in them, and they work much, much better that way. And night installation is a way to get around that. The Germans, I have to concede, are the masters at this. So apparently the Dutch are stealing stuff from the Germans, so steal this too. It's a good thing to take. I'm not going to talk a lot about mining, but I need to show you some pictures because it's a major use of geosynthetics. This is a tailings dam. Again, as humans on the planet, we ought to be ashamed of tailings dams. They're failing on a regular basis now, and this is where the economics have failed the sustainability again. The mine owners have taken the ore out, and they're left with this giant pile of waste. So what do? They plop it somewhere and they leave it. And on the fertilizer side, then in the United States, you made this giant pile of gypsum waste, and then you declared bankruptcy. And you said you didn't have the money to manage this giant pile of waste, and you walked away from it. And globally, the mine owners are doing similar things. Some more hydraulic applications, dredging, dewatering. I know that some of that plays very, very strongly here in the Netherlands. You guys have a lot of reclaimed land. You use geosynthetics by taking your dredging. You can put it in a geosynthetic tube, extract the water from it, you're left with the solids. You can use those solids for land creation. Again, for you guys particularly, a sustainable component to how geosynthetics can be used. Used for erosion control, this is a drainage channel that's lined with a geosynthetic that's capped with a concrete stone. Used for erosion protection. We've talked in the meeting before we started about rivers that have seasonal high flow. This is a good example of those walls there are reinforced with geosynthetic. There's a geogrid that goes into the wall to provide the stabilization, because when it rains, that river is going to become a raging torrent. Also, the same information happens on the coastal side. This is an area that has particularly high tides. So you see the geosynthetic bags down here as your principal barrier, and then you have geosynthetic reinforced walls protecting the tide from coming in and coming out, because as Kent illustrated, we build close to the coast, which is a really dumb thing to do. It's a very dangerous place to be. We do a lot of this for canals. Egypt is probably the site of the largest canal. They deviate probably 40 to 60% of the flow of the Nile River out to their agricultural land. If you don't line the canals, it's a desert. The water just all goes into the subsoil. So you have to line your canal, and there's multiple applications for this. And again, without a geosynthetic, you can't do this. It's not sustainable. I hate the topic of microplastics. We talked about it. It was mentioned a couple times. I'll point out here that geosynthetics can be part of the solution. This is the geonet that you were supposed to see a close-up picture of earlier. It's a woven net made out of polyethylene, and you can strap it around your waste water disposal pipes, and collect all the stuff that gets improperly thrown away. And improper disposal is the principal cause of microplastics, but that's a whole nother story that I'm not going to get into. The picture on the right is for those of you who think that microplastics are a third world problem. That's not something that we do in the civilized world. The picture on the right is a picture of the plastics that are collected along the bank of the Thames in London. A couple other bon mots, little side benefits. I just show you one slide so you know that this exists, barrier integrity surveys. When you put the geomembrane down, the most dangerous time for the geomembrane is when you're putting the soil over the top of it. That's when it usually gets damaged. It's possible to do an electronic leak location survey, ELLS, after the soil's been placed. You can test for leaks. I won't explain how, but you can, this apparatus, which is fairly simple and hooked up to a GPS, you can test and make sure your geomembrane barrier works properly. And you get an output that looks like that, and a hole is identified by different distances between those probes and the leak as that guy walks around with the probe and monitors. You also need to be concerned about interface friction. These need to be built at the right angle. If you build them too steep, the soil will slide off the geomembrane. So it's something you need to pay attention to. Okay, so let's digress. How am I doing on time?
You have
15 minutes, excellent. So let's use our numbers, shall we? If you're going to have sustainable behavior, you have to measure it. And if you don't measure it, you can't control it. And I'm not just throwing stones at Kent and Jorge, but the information that they presented for you is not the best way, not the current best practice to measure life cycle analysis and the impact of sustainability. Again, back to my F. Scott Fitzgerald quote, you need to keep this in perspective. These are various iterations of the telephone. Used to be you had to go to a phone booth to make a call, then you could do it at home, then you got the mobile phone from Motorola, and now we all have these little phones and computers and all that stuff. So there's an iteration going on here. One of the keys to this iteration is ISO, International Standards Organization. We all need to be doing it the same way. It does, like I said, we're all in this rowboat together. It doesn't work if we're doing it differently in Australia than in the United States, than in Brazil, than in South Africa, than in Italy, than here. So there are techniques and standardization protocols for how to measure the sustainability contributions of these products. And they run all off something very important called an environmental product declaration. An environmental product declaration is basically a statement by a manufacturer on the environmental impact of manufacturing their material. Where did the electricity come from? Is it hydropower? Is it nuclear? Is it recyclable? Is it a coal generation plant? How far do the raw materials have to come? All of these things are made out of plastic. So how that plastic carries an excavation and refining and polymerization load. All of that information is reflected in the EPDs. And there's guidelines for the EPDs on how they should actually be presented. So if I were buying something today, I would want an EPD from the manufacturer that said, this is how much energy and how much CO2 is emitted and how much water is consumed during the course of the manufacture of my product. These all feed into something called life cycle analysis. And I'm going to talk a little bit about what the IGS did, because the IGS deserves to be credited for leading the case on this. There are multiple life cycle analysis softwares that exist. I'm going to talk to you about one called One-Click LCA. It just happens to be the one we chose. It's one of the better ones, I think, but I'm a little biased. The IGS bought a multi-user license, and we hired a couple of academics, George Mason University and Barcelona Tech at UPC, to prepare templates. And these templates show the examples of the things you saw before. If you put a geosynthetic in a road, how much energy savings do you have? How much CO2 reduction do you have? So those templates are examples for our members to use. We launched the calculator in Rome September last year, and we were trying to promote it, and this training will become part of the IGS handbook, which is an important thing coming. I'll go through these fairly quickly. These are from the group in Barcelona. They talked about doing the life cycle analysis. And again, there's nothing wrong with this graph here. It's a very good graph, but I want you to take like a mental picture of it and compare this circa 2017 to what I'm going to show you in the next 5 minutes. The LCA covers a whole bunch of stages. It's all the way from cradle to grave. Raw material extraction. Where did I get the polymer that made this geosynthetic? How did it get to the manufacturing site? How much energy was used in manufacturing? How far did it have to go to get to the construction site? The installation and use. And then what happens at the end of life? At the end of life, does this stuff get recycled? Does it get reused? What happens to it? So there's all these stages, A1 to C4. I'm going to skip this one. And one-click LCA talks about the material, how far it goes, how far the shipment is, because transportation is expensive and a big CO2 emitter, how much waste, how long the service life is, and it draws all this data from the EPD, which is why the Environmental Product Declaration is so important. And you plug all that information into a case study. And all these case studies are I don't want to say they're theoretical, because they're not. They're based on real cases. But we address 1 square meter or 1 cubic meter of each case. And there are several of them. I'm going to take you back into the drainage one, go back to my river rock days. This is landfill drainage, where you're trying to collect the leachate that is percolated through a landfill. And there are basically 2 designs, and you see them highlighted down here. Gravel drain, which is the rounded river rock, if you can find it. And then the geosynthetic drain, which is the geosynthetic alternative to that. And here's the data input that you put in. You can look at water, you can look at energy, you can look at just about anything. And for each design, you put in a whole bunch of parameters. Now we're looking at the geosynthetic design. They're looking at 3 different types of geocomposite here. This is the quantity per square meter in kilograms, so you know how much you're using, how much CO2 is emitted, and then there's further additional detail on, for example, transportation. How far did these things come? You saw the picture from Kent that 1 truckload of geosynthetics equals 100-some trucks of compacted clay. So there's a huge geosynthetic benefit. And if you go further out to the right, and you can do the transport in stages. If it comes on a ship and then gets on a truck, you can account for that using this. How much waste there is, what happens to it at the end of life. And the design engineer puts all these in, and he says, okay, this is how much CO2, and I'll focus on CO2 for the rest of this, how much CO2 is being emitted by this project. And again, this all relates back to the EPD. This is the drop-down tab for the EPD. You can actually download the EPD that you're using here, so you know exactly what it is, but you can compare material from different manufacturers. Solmax, for example. Solmax has a plant in Varnes, Quebec that runs primarily on hydroelectric energy. That's very different than a plant that runs completely on coal-based electricity. So here's a drop-down of the 2 designs. And I'm going to go here and show you some of the results. This is what your outcome looks like, and this is sliced 6 ways from Sunday. But here you have your CO2 emission, and the blue bar is the traditional design methodology. The yellow bar is what the geosynthetic is. You can break this down by all of the various stages, those A1 through C4 stages, and look at where each of the stages generates electricity, or excuse me, generates CO2. Again, the big difference here being that yellow bar here is transportation, and you have a lot of transportation in the traditional methodology and very little transportation in the geosynthetic methodology. You can break this down by CO2 emission by the elements, how much is transport, how much is material. There's a whole bunch of different ways to do this. Here's the stages by transport and material. And this is what a complete life cycle analysis and sustainability contribution of geosynthetics should look like. If you're an IGS member, access to this is fairly easy. and we're planning on improving it. And there's all these templates for landfill lining, for roadway paving, stabilization, retaining walls. You compare a bunch of different designs. There's a huge difference between a geosynthetic retaining wall and a regular concrete retaining wall. So there's a whole bunch of stuff in here built in for you already to use. It's available free of charge. The templates are available. You have to know how to use one-click LCA, so there's a little complication there, but this is how you should present geosynthetic benefits using best practice. And this is the type of tool you're going to need to prevent somebody from solely considering the economic benefits. So, what do I want you to do? I want you to think. I want you to read. Please read one of those books that I recommended. Any one, pick one, but for God's sakes, please read something. And I want you to act. I want you to act differently. One of the biggest things about sustainability is that I'm just one person. There's 8.5 billion of us. There's nothing I can do that will make things different. Chinese proverb, a man who moves a mountain starts by carrying away a small stone. And a quote from Edmund Burke, nobody ever made a greater mistake than he who did nothing because he could only do a little. So make wise and informed individual consumer choices. Transport. Eliminate single-use packaging items. That's a contribution. Use more public transport. Don't buy another car. I've bought 18. I'm not going to buy any more of them. Recycle, recycle, recycle. Consider the population. One of my big gripes with the Mormons are that they're told to go out and have as many children as they possibly can. That's going to kill us all. Engineer and design with sustainability, and you have to give economic factors the proper consideration. If we do this following the economic guidelines, we as a species are going to fail. There have been a couple books written a couple years ago about how capitalism equals sociopathy. And that's what the tailings dams are, that's what the gypsum waste stacks are, is people not bearing the full economic responsibility for what they're doing to the environment. And we as a species just can't continue to do that. So I have to give some acknowledgments. There's a whole bunch of them. I'm not going to read them all off, but these photos were not all taken by me. They came from a variety of different organizations, including some individuals down there at the bottom. And don't thank me. Don't applaud. Change what you do. Just change one little frickin' thing, what you do, and I'll be happy. Don't applaud. Change, change, change. Do something different.